Okay, this is still experiment 26, resistors in series and parallel. This is part C, resistors in series parallel. So you can see here we have the battery, the switch, ammeter. And this current, this is the parallel portion. You can see it splits off into two branches, comes back, and this parallel branch is in series with this series resistor. So it's a parallel series, or they call it series parallel circuit. Now, what are we modeling that off of? Let's go to, let's find the circuit that's right there. So it's this here. The voltage. I kept the ammeter in it. We actually have redundant ammeters, but it goes into R3, R2, and then into R1. So you collapse to get the equivalent resistance. You first collapse these two, and then once you get that parallel equivalent, then it's in series with this R1. And of course, resistors in series, they just add, so you get the equivalent resistance is the R parallel equivalent plus R1. And then with that, you can get the current. You can get the current. Once you get the current through the total circuit, you can find the voltage that you would expect across the parallel. And if it's across the parallel, then it's across both of these simultaneously. And you can get the voltage across this one. And so we're going to do that. Let's do a new share and go to the, go here. Let's see, I've done some calculations. I'm going to call them out, but you're going to have to do your own calculations, and I want to see your work. So we're using 20 volts, the same 56 ohm, 100 ohm, and 120 ohm. You see the 120, the 100, and here's the 56. It's making up our series. Well, these two collapse to near 56. I want you to give me an exact value. The total current that we expect is 181 milliamps. I know it won't, you won't get 181 on here. It'll just probably say 180 or 0.18. That'll be the total current. The voltage across here should be about 9.87, and the voltage across here should be about 10.13. And I think that's enough information that we can go ahead and run this. Sure enough, it shows 180 milliamps in the total current. And notice that this is 180 milliamps also. And let's see. Yes, and in this branch, we've got, I calculated 82 milliamps, 0.082. They're showing 0.08. And I calculated for this branch 0.0986. It's rounding to 0.110 amps. So my calculations came out correct. You should get some calculations. And with these rounding, you should get some percent errors. Let's measure the voltage. Let's take a voltmeter, and first, if we measure here and here, we should get the entire 20 volts. Now let's measure this branch, and it says 9.87. 9.87 volts across this branch. And with that 9.87, you can calculate the expected current in each branch, and it should come out close to what it shows here, 0.08 and 0.10. And then let's measure across this, and it's 10.13, and that's exactly what I calculated. So I want to see your calculations for determining the current through each branch and the voltage drop across these two and this one. Okay, I think that's enough, and we'll end it here.